Dear No Science Academy nerds, this is your Sazzad Sir. After a long time, I am making video for you. Today's topic is moment of force and equilibrium. So before that, I will try to incorporate some short videos, practical examples. You know that, okay? You see and be inquisitive then. Dear student, carpenter knows more science, physics than us. How I am proving? If I push, I give force here, see, it is very difficult to push the door. Now, I am giving force here, not with this finger I can push, see, it is so easy. Okay, that's why carpenter use the handle here, away from the hinge. Now come to this, we give force on the paddle, correct? This distance is more, this diameter is more, this distance is more, and see this diameter is less, okay? So distance is less. So when I am paddling this, okay, cycle moves very easily. That's why scientists, engineers do this arrangement. This diameter is more, so my force applied will be less. Thank you. Dear student, today we will discuss the moment of force and equilibrium. Before that, we want to discuss the motion. Motion, translatory motion, rotatory motion and mixed motion. There is other form of motion that is periodic motion, simple harmonic motion, pendulum moving, wave motion. This comes in simple harmonic motion. After some time, it repeats its phase. Okay, that is today our discuss is limited to translatory motion and rotational motion. There is centrifugal force, centripetal force. Later in the next episode, I will teach you. Now, what is translatory motion? Say this is. So this cup is here. I am giving force. It moves straight way. What happened? Every point of these moves equal distance in a straight line, maybe curved line. That is straight line, translatory motion. Okay. Now see, sir, this is the cup. I am giving force here. What happened? It rotates. How, sir? We can discuss in this way. This is a box lying on the table. I am giving force here, force. So this comes here. So this point moves here, this point moves here, this point moves here, this here. I can say this is translatory motion. Okay. Now, if your door is there, door is pivoted at some point, hinge, we tell them hinge or pivot, and I am giving force here. What will happen? The hinge is there, it will rotate in this direction. It is anti-clockwise, or I can say CCW, counter-clockwise. If I give force downward direction, it will move in the clockwise direction. Clear? This is rotational motion. Rotational motion, you know, a stone tied with a string, you rotate it. You will feel some force, tension force here. Okay? Next chapter, I will discuss that. This is called torque. Torque. This is force. This is distance. Perpendicular distance from the pivot or hinge. Pivot or hinge. This distance is d. That torque will be force into perpendicular distance between the pivot or hinge and this. I am taking this as d. I can say this is r. This is better. R. R. Okay. Unit. Force এর unit হচ্ছে Newton. It is meter. Okay. But for work you know, work equal to force into displacement. Force into displacement. That unit also Newton meter. But don't say that as Newton meter. You have to tell that joule. Agreed? It is joule. Both are same. But you have to tell joule, here Newton meter. Newton meter clockwise, anti-clockwise. Best example, seesaw. Seesaw. Or common balance in the market, vegetable market. Common balance is there. Now, on the seesaw, you can see two child is here. And they moves in this direction. Actually it moves in this direction and this moves in this direction. This is clockwise and this is counterclockwise. CCW, anti-clockwise. When it will be equilibrium? When both of them are produces same moment. That is force into displacement, force into displacement. That will be in equilibrium. Sir, say you are fat man, okay, and your student, say you are very thin. You sit here. Say you are 50 kgf. Your mass is 50 kg. I am taking it as gravitational unit. I am telling it as 50 kgf. I am 80 kgf. Where I will sit? If I sit here, distance is same. So you will be up. Okay. So what? I will sit here. My distance is less. Counterclockwise and clockwise moment. This moment and this moment. This is counterclockwise and this is also counterclockwise. What happened? No. This moment is clockwise and this moment is counterclockwise. Both will be same. Then we will be in equilibrium. Finish. Very easy. Now you can see. In the common balance, like this, at the center there is a rope, etc. Here is the 1 kg or 2 kg and they measure the mass of the vegetable, say. When it becomes horizontal, you are assured that it is 1 kg or 2 kg, whatever. Now, sir, moment equal to force into distance. What distance? Perpendicular distance from the pivot point. Now, sir, I am twisting the question. You know that trigonometry? Here trigonometry will be applied. আচ্ছা, এখানে আরেকখানা বলি, class 9 4th chapter you read how we walk. Actually force can be resolved into two components. On the ground we are giving force in this direction. Okay, ground is giving opposite reaction force. if F is this, force can be resolved into two components. One is this horizontal, one is vertical. Now, class 9 পড়াচ্ছি. This theta, this is theta. It is F, force. This component will be F cos theta. And this component will be F sin theta. Trigonometric table, standard angle table, আমি একবার করছি. 0 degree, 30 degree, 45 degree, 60 degree standard angle, 90 degree. If they give any tricky sum, you apply this technique, please. That's why I am discussing here. Sin 0 degree, 0. Sin 30, 1 by 2. Sin 45, 1 by root 2. Sin 60, root 3 by 2. Sin 90, 1. Cos, reverse, 1. Root 3 by 2. 1 by root 2. 1 by 2, 0. Please trigonometry, from trigonometry you remember this, learn this. I am coming to another sums application of this. Sir, this is a rod. It is pivoted here. I am giving one force here. How much? Very good. It is 4 Newton. Now I am taking F1. Here moment calculation is very easy. Okay. Torque. Force into displacement. 2 Newton. Distance, not displacement, distance from the hinge. It is 5 Newton meter equal to 10 Newton meter. It is which direction? Now I know this component will be F sin theta. F sin theta. And this component will be F cos theta. Okay. This component I am giving force in this. So F sin theta. F sin theta, it is 4 Newton. 4 Newton into sine 30 degree. 30 degree. 4 into sine 30 is half. 2 Newton. This is 2 Newton. 2 Newton force is acting, and from the hinge the distance is 2 meter. তাহলে torque, in this case torque will be 4 sin theta into distance হচ্ছে 2 meter. So it will be 4 sin 30 into 2. It will be 2 into 2. 4 Newton meter. Which side, sir? This is also clockwise. I am pulling this side. This. That total torque, if it is T1, it is T2, total torque will be T1 plus T2 clockwise. That is আগেরটা হলো 10 plus 4 Newton meter. That is 14 Newton meter. A half meter rigid rod, that is 50 centimeter rigid rod, is pivoted at the center. 20 gram force and 12 gram force weight is suspended from 6 centimeter and 10 centimeter from the pivot. Which force causes clockwise moment? This force causes clockwise moment. Okay, this force causes clockwise moment. This is in this direction, clockwise, and this is anti-clockwise. Now clockwise moment কত হবে? 12 into 10 gram force centimeter, that is 120 gram force centimeter. Very easy. Is the rod is in equilibrium? Clockwise moment is this. According to principle of moment, clockwise and anti-clockwise moment will be same, then it will be equilibrium. Okay, equilibrium, there are static, dynamic, static equilibrium, dynamic equilibrium. Equilibrium how? When I am jumping from this to this. Okay, please try. I will give photo also, study material. Now a body, rigid body is here, okay, on the table. Weight is acting in this direction, weight. I am pushing this F1. Frictional force acts in this direction, FF, frictional force. The body is not moving. So many forces are there. Resultant displacement 0. I can say it is at equilibrium, static equilibrium. A heavy box I am pushing, I cannot do anything. Work done is 0 also. That is work power energy te porabo. Net moment if 0, clockwise, anti-clockwise. Net moment if 0, then it is in equilibrium. Sir, what is dynamic equilibrium, sir? Newton's second law of motion. Okay, when acceleration is 0, acceleration is 0 means constant velocity a body is moving. It is dynamic equilibrium. So many, I am moving a car with constant velocity. Frictional force, air resistance, weight, everything is acting, but it is moving with constant velocity. That is dynamic equilibrium. Neutral equilibrium is there. It is out of scope. That's why I am not telling. Video will be long. Now here I can say clockwise moment and anti-clockwise moment are same, equal. Then I can say. And here I can say resultant is 0. Resultant of the force is 0. Two condition I am telling. Now here come equilibrium. This is clockwise. I am getting counterclockwise, anti-clockwise. I am getting this 20 into 6 gram force centimeter. 120 gram force centimeter. So I can say it is in equilibrium. Third question, if 20 gram force weight is reversed, I am giving this 20 gram force weight, reversing this. Okay, that means if I give this direction force, okay, then it will be clockwise. It is clockwise, it will tilt in this direction. Okay, তাহলে কত হবে 120 clockwise gram force centimeter plus 120 gram force centimeter. Total clockwise moment will be this 240 gram force centimeter. I think it is clear. I will come to another thing. Okay, a non-uniform meter scale of weight 50 gram force can be balanced at 40 centimeter without any weight suspended on it. if this ruler is cut at its center, then state which part 0 to 50 centimeter or 50 to 100 centimeter of the ruler will weigh more than 25 GF. Now sir, one thing I have to tell you, I will try to make a short video. Say this is non-uniform meter rule. This is non-uniform meter rule. Okay, pivoted here. It is 50 gram force acting at the pivot. It is balanced. Say I am taking two weight, W1 and W2. This is 0, this is 100, this is 40. At the near end, W1, blindly you can say W1 greater than W2. We will prove this. Okay? Near end to the pivot, it will be more. Okay? Now, 50 gram force is balanced. It is this. It is not like this. It is this. So, it is W1. It is W2. So, W1 plus W2 equal to 50 gram force. I can say W1 equal to 50 minus W2 gram force. Okay. Now I will do, this is anti-clockwise moment, this is clockwise moment. Okay. W1 into this distance is 40 equal to W2, this distance is 60. Sir, W1 equal to 50 minus W2. 50 minus W2 into 40 equal to W2. I am converting W1 into W2 into 60. 4 5 20 2 to 0 minus 40 W2 equal to 60 W2. 40 will come here, 60 plus 40, 100. 100 W2 equal to 2000. What happened? W2 equal to 40 gram force. W2, 20 gram force. It is 20 gram force. 20 gram force. W1 will be total W1 plus W2 50. তাহলে 50 minus 20 gram force. This is 30 gram force. 30 gram force. More than 25 gram force. Of course, this is, as because it is non-uniform, it is more than 30 gram force. This part. Theoretically, I told, if it is shifted here, if it shifted here, then this force will be more. Near end will be, force will be more. Practically, you can take your two finger like this, okay. Now, tell your friend to give at the center force. You will feel same pain on these two fingers, okay. But if your friend shifts his point of application of the force, near end you will feel more pain, okay. It is theoretically concept. Clear? Now sir, second part কি ছিল? Second part, total weight is 50 gram force. 50 gram force. It acts at 40 marks. That's why it was balanced. Now I am shifting the pivot here, fulcrum here at the center. So it will bend in this way. What minimum force I have to give such that it will be again balanced? Of course, from here, sir, say W. Okay. Now, if you take moment clockwise, no, it is anti-clockwise. 50 gram force into this distance, 50 minus 40, 10, equal to W, this distance, 50. So, W will be 50 cancel, 10 gram force. I have to apply minimum 10 gram force at this point so that it will be balanced. Now I am taking 3 pictures. One is, this is pivot. Say it is a car wheel. I am giving F1 force here. It will not rotate. It will be equilibrium. If I give force in this direction, it will move. So this is pivoted. If I give force here, it will rotate. I am giving force here, but another force I am giving such that it will not rotate. What I will do? Say I am giving the force, this is clockwise direction. If I give force here, this will be clockwise. So I have to give force here. F2. It will not rotate. Both will balanced torque. Sir, F1 equal to F2 or F1 greater than 3 condition. F1 equal to F2, F1 greater than F2 and F1 less than F2. Which will be there? Sir, moment I told you force into displacement. This displacement, if it is O, this displacement is this. Torque clockwise, force into displacement. This F1 into, it is if A being OA. Now sir, here the displacement will be this. No sir. This? No sir. Because it is not perpendicular distance. Then this will be, I am drawing this. Say it is A dash. Sir, common sense, this distance A dash O less than AO. Distance, perpendicular distance is less. So what will happen? F2 more force I have to give because moments will be same, then it will not rotate. Tamne F2 greater than F1. First point I think clear. Second thing, this I am coming to. Say it is the stair in the building. A ball is here. I can give at different point force. At different point. Okay. Which will be minimum force such that ball will come to this. Sir, in a circle, diameter is the biggest chord. Diameter is the biggest chord. So I will make, point of contact is this. I will join this. Then I have to give tangential force. From the tangential force, it will be F minimum. Now clear, I think. If in the question paper you get point of contact is there, I have to rotate this, I have to give this, then it will come here. So what? From the center you join these 2 points, here it is tangent. Finish. Sir, I want to do another thing. This is a wheel. F1 force is acting here in this direction. Which one is greater, smaller, and in between? This distance, perpendicular distance, direction of force and perpendicular distance is this. Agreed, sir? If I draw this force, এটা ব্লু দিয়ে করি না, এটা রেড করলাম, এটা ব্ল্যাক দিয়ে করি। Agreed? With respect to this, perpendicular distance is this, very less. And if I draw this with respect to this, now you can say F1 distance is more. F1 will be minimum. Distance is more, perpendicular distance. Now we are coming another topics. F1 force acting here, F2 force acting here. Okay, and this distance from O is 1 meter. This distance is 1 meter. Say equal. I am counting moment about y. Moment about y. This force acts on the y. So distance is 0. If I give force, this is a door, I am giving a force at the hinge, nothing will happen. 0. Moment is 0 because distance is 0. Moment is force into perpendicular distance. This will be 0. This F1 5 Newton into about y, so distance is 2 equal to 10 Newton meter. Clear? About O, moment about O. Acha, direction, this is clockwise. Clear? Now, two opposite force, parallel force, opposite parallel force acting. I can tell them as couple. Husband and wife, couple. Okay, here two opposite force about the axis are acting, parallel force. Okay, then it will rotate in the tap, etc., whatever. You see, couple. Steering, you are using, this force is acting this force is acting this. No? Couple. Acha, another force I have to tell you. When rotary motion, two forces acts, na? Sir, on the door, it is the pivot. I am giving force here. It moves. I am applying single force. Okay? No. Actually, at the hinge, opposite reaction force acts. You are giving force in this direction. This force is this. This is couple. Couple giving rotation. Now moment about O. This is F1 into 1, no, 1 meter, force into displacement 1 meter. It is clockwise. This is F2 into from O1. It is also clockwise, sir. তাহলে F1 5 Newton meter, 5 Newton meter clockwise plus 5 Newton meter clockwise, that is 10 Newton meter. Sir, both is coming same. Now we will shift to the couple. Now couple. Two equal and opposite parallel force not acting the same line. If this force, say 5 Newton acting in this direction, I am giving another 5 Newton force in this way, same line, then it will not form the couple. When couple is formed, when I am giving a force 5 Newton, say this side, okay, and parallel, opposite, 5 Newton. Then it will cause rotation. Couple, parallel, opposite direction. If this is here O, okay, this forms couple. কত হবে 5, say it is 10, total is 10, okay, this total is 10. তার মানে this will be 5 meter, this will be 5 meter. Perpendicular distance 5 meter, 5 meter, 5 into 5, 25 Newton meter. No Science Academy notes. I try to make the video informative. Please, I have request, send me whatever sums, etc., whatever suggestion, please send me. And it is humble request, if you like the video, and go through the book, okay, and share it. Okay, bye.